Hey guys, sorry, just setting up my sound. Can you guys hear me okay? Can you type a 1 in the chat if you can hear me? Hey Andrew. Yeah, let's have a hello from everyone. So it's hi from Andrew. And I'm sorry, I don't know how to pronounce your name. Sergian? Am I spelling that right? And Philip, hey man. Hey Evan. So we've got 6 so far. I had about 20 respond back to the email. So we've got about, yeah, okay, we're waiting for one more to come in. Hang on, Miljan. Can I just say while we're waiting as well that I appreciate you guys coming along, taking an hour out of your Sunday, presumably a day off, to listen to a random guy talking about MySQL. Okay, we're waiting for this guy to join. Can you guys hear me okay? Can you just say yes if you can hear me? Ah, thanks. Is it clear? Like, you can hear me clearly, right? Because I have the microphone on my laptop, but I've also bought these snazzy new headphones which have a built-in mic. All good here, Ivan. Cheers, man. It's okay. Cool. Okay, Milton's gone. That's a bit rude. Right, okay. Do you guys see the link at the top of the chat for the PDF? You'll all have this, but just for convenience, I will link it. If you guys want to open that up. By the way, can you guys see the whiteboard with the blue text? SQL Stage Webinar. Can I just get a yes for quick if we can see the blue text on the whiteboard? You can. I'm sorry about the the constant reassurance, because this is my first webinar, guys, so you guys are really nice. Thank you. Getting lots of yeses in. Right, okay. Cheers, Philip. So it looks like we've got a mix of people here. So what kind of countries are you guys from? Where are you all joining us from today? I'm in England, by the way. Philip's from Croatia. I went to Croatia in July, actually, for a holiday. Serbia. 2 guys from Serbia. Awesome. Three guys from Serbia. Wow. Are you guys friends? Oh, Belarus. Guy from works from Belarus, actually. Oh, awesome. Philip, where in Croatia are you from? Okay, Zagreb, yeah. I have some family who went there last summer. I went to Split on the coast. Beautiful, beautiful town. Much better than here today in the UK. I'm in England, by the way. So I'm in northwest of England, and it's pretty crap here today, actually. It's about 6 inches of snow. It isn't a lot, but just kind of inconveniences everything. Okay. So I'm going to ask one more question before we get started. Okay. So you guys are all developers, I take it? What job titles do you guys have? Are you developers? Like, I presume you all work with MySQL and MariaDB, that kind of thing, right? Yeah. Yeah. What kind of languages? Like, obviously MySQL, but what other like languages do you code in? Any other PHP developers? That's what I do. Ivan's a beginner? Awesome. So how long have you been doing this, Ivan? Like, how long? Are you still learning? That's cool. Well, you're in the perfect place. Learning PHP. Oh, awesome, man. I do PHP. Done this for a few years now. So PHP is the main language that I code in, but my job that I do 9 to 5 every day is kind of leaning towards MySQL, becoming more of a DBA. That's awesome, man. I'm sorry, man. How do I pronounce your name? I'm really sorry. It's not a name that we usually have in the UK. Oh, Java. Yeah, man. Java's an awesome language. It's a lot stricter. Like PHP, you can just write any old crap and it works. No, that's oversimplification. Some guy, Ivan says C# as well. So you like pain? Awesome. Okay, thanks for those replies. A lot you can't imagine. I can imagine a lot, Ivan. I've had to launch products by myself with project owners emailing me like the night before a launch. Could you add this? Could you add this service to it? And I'm like, you launch in 2 hours, man. So I can imagine a lot, Ivan. Smiley face, nice. Okay, so you guys didn't come here just for a chat. I want to talk a bit more about SQL Sage, why I'm doing this. So I've worked as a developer for a number of years now, and as I worked in a kind of small startup, I found that you have to take on a lot of roles besides your own job. And this is something that maybe you guys will learn. The guys who are new to this will learn that. Like, if you join a big company, normally like it's all set and your job role's more defined. But in a startup, it's like you do everything. And I've basically had to learn how to administer MySQL databases from scratch, I might add. I mean, going back many years now, and I started learning MySQL. And it was like basic stuff, learning just how to do like joins and stuff. But because I've had to launch products basically myself for the company that I work for, I've had to very quickly like learn a lot of stuff. And once the company that I work for got quite established, we got a lot more developers in who were just PHP or just JavaScript, which is cool. But I often had to like guide them through how to learn MySQL as well, because all the databases is in MySQL. And as one of the kind of senior developers at the company, I've had to do a lot of the training of developers that have come in. And like, not all these developers who've come in are like brand new to PHP or MySQL. Like, they're like experienced. They've got like 5+ years experience. So, you know, they should know more than they do. And I don't want to go into bashing my own company right now. But I've noticed patterns over the years that I've been doing this. I've noticed a lot of patterns for developers and the mistakes they made in MySQL databases. Stuff that's like slowed down the website. And like obviously any app nowadays, right? You want, instant loading, like everything to be instant. Like you use Facebook. Like can we all appreciate just like the speed of Facebook compared to the amount of data they have to search? I mean, like, can you imagine the size of the databases they have to do? And like they did use MySQL. I mean, I don't work at Facebook, so I don't know this, but I imagine they've forked it and made like their own sort of version of MySQL database, some kind of relational database system. And I think I read somewhere that they receive like, I don't know the exact number, so I'm talking out my ass here, but like 10 exabytes data a day. Just from every like that you do on Facebook has to be stored somewhere and fetched. And like when you go on the website, or your newsfeed even, sorry, not website, newsfeed, like it's all just there. And that's the kind of thing we aim for in developing, isn't it? We don't want like a shitty, slow website because it's embarrassing. And you can get as good at PHP as you want, but if you don't have the knowledge or the skills to write fast queries and design your schema, and when I say schema, I mean databases and tables, and you're still screwed, right? So, like, my main goal with SQL Sage is to address that and go out in the internet and help people learn this stuff, right? And this, like what I talked about before about like helping developers and sort of training them to do MySQL queries better, those experiences were the main points I wrote for in MySQL Worst Practices. Like you guys have all downloaded that, right? Like that's how you guys found out about this whole newsletter, right? And that's how you got this webinar. So like a lot of the things I cover, like I'm very passionate about, like with indexes, partitions, table design in general. I'm going to repeat, but it's because they're kind of like foundational topics. And it can depend on the size of the tables that you have. So like if you're just, if you're new and you're just testing stuff and you've got your own like sandbox. So like a few guys know PHP, like you've heard of Laravel, right? They have their Homestead Vagrant box, which is like a virtual machine that you can download, and it has MySQL pre-built. And you can like connect to it and just test out tables and just create stuff when you want. That's something I'd recommend you do, like if you are new. And just like just write scripts to like make massive tables and just test like selecting from them and that kind of thing. That's the best way of doing this. I mean, aside from like building your own app in your own time. Okay, so real quick, what kind of database sizes are you guys used to working with? Could you like write in the chat to like the size of tables you work with? Like if like I know some of you guys are brand new, but if you can like put it in the chat, like 10 gigs, 10 megabytes. See if we can try and get this. So I mean, like the answer itself, like don't worry, like if it's like you yeah, exactly. Yes, that's true, man. Don't worry about it. I mean, it doesn't matter if like you're working with 20 terabytes, 20 gigabytes, 20 megabytes. These things all matter. I mean, there are certain levels to this stuff. Like what I'm going to teach you a lot today for like indexing. If you know indexing very well and you get a job as a developer, you're going to be ahead of like most of the developers there. I'm not even kidding. Like most developers who come into our company, they don't know shit about this kind of stuff. So you're going to be really ahead of them. But like when you get ahead to the level of like managing database applications, like big applications where it's like, you're managing hundreds of gigabytes of data, then stuff like partitioning is going to be really important. I'm not saying it's not important to learn now. It's just you don't necessarily need to know about it yet. Like, what you'll find is, like, if you get a job as a developer for a big company, I mean, a few of you might already be developers at big companies. You'll know what I mean. Like, you learn stuff on the job to try and solve problems as you go. And that's the most important thing to take away from this whole thing, I think. That's how I've learned. Like, I don't have an official MySQL training certification because while you can go on these expensive training courses, they're not worth it. The best learning you can do is in a job, solving problems yourself. And if you've got a good employer, they'll trust you to to work out solutions and solve problems yourself. Okay. You agree, yeah. Yeah. It's okay, I know what you meant. That's good that you agree, yeah. Okay. Right. So, I'm new to Click meetings, so I apologize if I mess up. Anyway, I'm recording this, by the way. So, I'm recording this entire presentation. So, I write it into an MP4 file. And if you want it, just email me, I'll send it to you. In fact, there's only 6 of you here, so I think I might just send it out. Right. Okay. I'm going to try and share my desktop with you so you can see MySQL Worst Practices. In the meantime, can you just open up the PDF, please? And while I try and open this. Connecting. Right. Okay. Show your screen. Right. Full screen. You can see this, right? Can you put in the chat if you can see this, the desktop? Cheers. Thank you. Thanks, guys. Thanks, Ivan. Okay. So, I mean, like, I don't know what your setup is in your laptop. Like, if you have like one screen or two screens, like you can have the PDF open in one screen yourself, and I'll have it open here because I want to see the chat as well. Okay, I'm gonna flick between. Okay. Right. Okay. So MySQL Worst Practices, yeah, this is the PDF that I've given out. I could open chat here as well. So can you guys see this as well, this chat? I'm sorry if you can. I didn't mean to, like, hope it isn't distracting. It's just so I can see your responses in the chat. Okay. Right. Okay. So MySQL and MariaDB, 2 most popular database engines in the world. They're rightly chosen for their speed, potential, portability, and the fact that they're free. So MariaDB actually isn't one of the most popular ones. The most popular ones are actually MySQL, and I think it's Oracle and the IBM one that are most popular. But MySQL, probably among open source, is by far the most popular, and it's so easy to pick up and use. Okay, so you want to grow your app into a successful business, and to achieve that you need one or more of the following: lots of users and lots of data. So either of those needs a database that'll scale well, because if you've got a shitty database set up that's really slow, when you get to 10,000 users, they're going to have a bad time, right? So this guy will take you through the most common mistakes developers make with the databases. Okay, so I hope that by reading this, you'll know how to avoid all these mistakes and fulfill the speed potential of your app. Okay, so mistake number 1, you're doing indexes wrong. So I like to rant a lot about indexes, and by far the kind of most common go-to solution I have in my job when going through problems with developers who say like, the site's loading slow, or there's too much load on the server. I instantly look at the table that's being queried, and 9 times out of 10, they've not indexed it properly. So as your database grows, so whether you've got a 10 gigabyte table or a 10 terabyte table, a MySQL index is absolutely vital. They take a huge load off the server because it's much easier to look at values that way. So as an example, I mean, imagine you have a massive book in front of you. So like, imagine like the Bible or some like massive book that has like thousands and thousands of pages, like War and Peace. So if somebody said to you like, okay, Ivan, like find this word in this book, you'd be like, oh shit, how do I do this? It's hard, right? I mean, at the front of every book and at the back, you have a content section and an index. So you can say, okay, this word appears on this page. So you can go straight to that page and find it instantly. So that's basically an example of using an index for a database, isn't it? If you've got like a table of users and you've got millions of users in your app, you don't want your table to have to search every single row. Because if you have no indexes, that's what will happen. To find a section in the book that we had before, Ivan, you'd have to flick through and look at every single paragraph. So you have to start from scratch, from the start, and go all the way through the book until you found the section you're after. Does that make sense? And by the way, that's called a full table scan in MySQL if you have no indexes on your table. It's actually like, it's quite funny because like, it's one of the most easiest things to learn and do, and yet so many developers don't do it. And like I've put here, like if you had a really, let me highlight this. Oh, can I highlight this? How do I do this? No, it's not working. Okay, man. Sorry. So if you had a really efficient content section and index, you know exactly where in the table to look at. Much faster, much less work involved for the same result. And if you have your MySQL server set up properly, so the actual configure the server set up properly, all this will be in memory. So with tables that are on disk, because your database do sit on disk in MySQL, it's a bit slow to actually query that data compared to memory. I mean, like it might be fast. Like if you have like, do you guys have SSDs in your computers? Like in your laptops, like SSD drives rather than hard drives? Like it's fast, but memory is like, I don't know the exact, but it's, you know, thousands of times faster. It might have been faster than that. I will get to that later in the guide. So I want to go through 2 sections of this webinar. So we're going to go through this PDF. I'm going to go through the cheat sheet I sent out a few weeks ago. Okay, sorry, go back to this. Okay, so like the way to think of it is like it's contents chapter page, right? So the way table indexing works in MySQL is that each index you make will always have the primary key appended onto it. And this kind of explains why indexes work so quickly, not just a random fact. So if you think about the page numbers in the book as the book's primary key, if you're thinking of the book as a table, you see how this works. So you've got contents page or index from the chapter, from the page. Or even if you're lucky, you'll have an index section. So like if I have an extra one, an index section at the end of the book towards an actual page. It's even easier. So in MySQL, it's the same principle. So it's index to the primary key to the actual row. And that's an important thing to remember, is that on every index you have in your table, the primary key is implicitly added to the end of it. So even though you might have only 2 keys, you actually have the primary key implicitly added to each one. And that can add size, but if you think about it, it's a worthwhile size to add for user convenience. Okay. So, okay, towards the end of this, so write your indexes for your most common select queries. So in MySQL, anytime you write a query like this, so you see here, like select star from table where column equals value in string. MySQL will attempt to find an index on column, so this column here, because you're doing a direct lookup on this column. So you're saying like where this equals this. So in your code, wherever you have queries like this, you always want to index those columns. You can get more complicated than this actually. Like if you have, let me just pull this up, sorry. Right. Sorry. Okay. Like if this column has many different values, then it's going to be faster. And we call that cardinality of a column. So like if you have like millions of rows and every row the column is different, some ID is different, it'll be an easy job for the index. But if you have like just 0 and 1 on that column, like we often call that a flag column or a flag field. So like on or off. That's quite a low cardinality index. It's actually an interesting fact actually, like if you have an index, but for any given value, it doesn't filter down to 20%, or less than 20% rather, of all the values, it won't actually use the index. So that is one kind of like reversal, like caveat for that. So if you have like 0 and 1, don't think that's going to be really quick with indexes. I mean, it'll be quick for like a small table, like megabytes, but like when you get to like gigabytes and over, like you'll start to see like slow down. Okay, right. So go through your code base, find queries, and do it that way. Okay, mistake number 2. So you're not using composite indexes. So in MySQL, you can create indexes on multiple columns, and it can greatly improve the speeds of your more complicated queries. But the order of the columns in the index matters, so you can't just add them in any random order. And whenever I talk to developers, like I mentioned before, about MySQL, their understanding is that like, oh, MySQL uses filtering, like it's just kind of elastic. Like if I just add loads of like where queries, it'll just filter down. You know, like why isn't it like, oh, only one, oh, about 10% of the values are this, why isn't it filtering down? Well, it's because the MySQL indexing, and this is the same in MariaDB, uses the B-tree algorithm with indexes. Now, you don't have to necessarily know too much about what that is, because it's quite complicated, but like it means that any columns with where a column equals ... so some value with direct equality, will always be prioritized first. That is very important, don't forget it. So MySQL, say if you have like, let me just type an example in the chat. So if I put like where col1 equals 1 and col2 equals 2 and col3 equals 3, like this. So like if you had an index, that'd be fine. That'd be fine because you've got equals on each one. But if you had let me type this. I can just about see that myself, actually. It's quite small. Right. So like in that scenario where you've got col2 more than 2, that isn't going to work with that index. You would basically get up to column 2. So you've got col1 equals 1 and col2 more than some value. So that is equality, and more than is range. So the examples of range are, so let me type these in. So when you've got a more than, a less than, so between, and that sort of thing. I mean, like, it's also the same for like that, and with equality as well. The idea being, guys, that like if you've got loads of like equals, it's fine. But as soon as you've got a more than, the index will stop there. It can't do more than one of those. So like range lookups are anywhere you have more than, less than, between, and your where clauses. They can be added next. You can only add one of them in your index. And columns in a group by or an order by may also be added next, but not if you already have arrange lookup in your query. So like if you have order by col1, col2, col3, use something like this, that's fine. You've got 3, and the default sorting for order by in MySQL is ascending. But if you did something like this, order by col1, that's not okay. Okay. Yeah, that's not okay. Because see how you're switching from ask to desk to ask? Yeah? That switching of the orders means that you will only go up to col2 in that index. And the exact same goes for group by as well. So group by and order by are very similar in MySQL and the results that you get. Because a group by will also order. So just for basically the exact same thing, guys. Like that. It's the same. Group by will also order for you if you ask it to. Okay. So now we're here. So by the way, guys, we're on page 4 now. So I should have said the pages before. So that sounds a bit like, well, that's quite a lot, John, to remember. You've actually got the algorithm that I put out here for writing composite indexes. So you can use this, so you can keep this PDF yourself and use it. This is yours. And you can keep it at work and you can use it whenever you want. So here's the algorithm for writing the perfect composite key for your multi-column select query. So add all columns in any order where you use where column equals something with direct equality, so that's the important part. And then number 2, part of the algorithm, add columns from only the first condition below that your query satisfies. So this is for your where clause, like the same as above the equals. So A column in a range lookup with a more than, less than, or between. Okay? B, all columns in a group by list, but only if they're in the same ask or desk order. And C, all columns in an order by list, but only if they're in the same ask or desk order. So this is important, like you can only choose one of these when you're writing queries. You can't have all 3. Does that make sense, guys? Give me a yes in the chat real quick. Does that make sense? If you're still with us. Okay. Okay, so the next one, right. So you're wrapping where clauses inside functions. Right, okay. So basically what I'm talking about here is, if you got this query, you can all see this, right? So select star from table where, and then you've got some column equals some other value. So it's like a hex equals some value. But you've actually got the hex function wrapped around the column. So no matter what you've got on that table, even if you had like an index on some column, the perfect index, that won't get used because you've got a function wrapped around the column. And this makes sense because if you've got an index, but you're saying, actually change all the values, how is MySQL going to know what order they're going to be in, what the value is going to be beforehand? It has no idea. So it's not going to use it. That's an important takeaway. So my top tip here was structure your data in your tables so that you don't have to use those functions in where clauses. So like here, where you've got hex or some value equals FFAA, store it as a hex. If in your app you need hex, store it as hex. Don't do this. Don't store it as binary, string, whatever. Just store it in the way that you want to use it. There's no point in doing extra work and putting your server under extra load. Okay? And the same here. Round latitude between 50 and 52. Just store it as an integer if you need it like that. I don't even know why you would need this. You could still like, this is kind of a bad example, but like you could always just store it as an integer. Or you can even, on a float column, you can just do between 2 integers, it's fine. The point is just don't wrap functions around columns and expect to use the index, because it won't. Okay. Mistake number 4. Okay. So you're using overuse. Sorry. You're overusing wildcard lookups for text searches. So MySQL can be used for search engines, but it's not really its optimal use. I mean, if you want to do that, then I recommend you look into Elasticsearch, because that is sort of the right tool for that job, for searching, like doing fuzzy searches. Like, say someone says, I want something like the word search. You do this, right, in your query. So where column like search. So column like search. And what this does is, if you're not really aware, see the percentages? These are wildcards. So this is saying any row where column has just the text search in it. So it can start with like any random stuff. It doesn't matter. I just want a string with that. So that's fine on a small table, but whenever you have the wildcard in front of the string, it's not going to use the index. If you're going to use the wildcard, put it at the end. And by the way, guys, when you have a like, that counts as a range. So it's like the more than, less than, between. So I recommend in MySQL, if you want to do something like this, use the match against syntax. Are we all familiar with that? We'll use that. Give me a yes or a no. So my top tip here is to use wildcard lookup sparingly, and definitely don't put the wildcard at the beginning of the search term. Okay, so we're getting close to the end now of this PDF. So mistake number 5, you're writing redundant indexes. So I rant a lot about having indexes and how awesome they are for performance and how just basic they are, but it is possible to actually put too many indexes in. So this is kind of like a reversal, like caveat of the first point. So what I'm putting here is like, if you have an index, so like column 1, column 2, then any query on column 1 alone will use an index. So if you have like this, and if you put like col1 equals like that. So I'm putting this in the chat, by the way, guys, if you want to look at it. Okay, so that'll be fine. That will use the index that we put up there. But if you did this, that would not use the index by itself. So if you put col2 by itself, that would use the index. And the reason for that is because it's on the end of the index. You've put nothing to search on col1. If you did, however, do this, if you put col1 equals blah, and that'd be super, super quick, really quick, because you're using both fields in the composite key. Composite keys are awesome, guys. Definitely use them. They can really, really speed up your queries. But remember to use my, well, I didn't really come up with this, but I read about it, and you use the algorithm in the PDF to write composite keys for your queries. Okay. So the point of this point is that having indexes takes up a lot of space. You'd be surprised at how big indexes can be. Like my stuff that I do, indexes can be as big as the table itself. And that's okay. Like space is actually quite cheap. But the point is that like you have to be wary of space. And as long as you're aware of the space, it's fine. But also like there is overhead to having indexes, and if you're trying to cram index into memory and you've got too many, it's going to be a bad time, and it's going to be worse. But I mean, like, don't worry too much about this. I mean, like, if you're just getting started, just write indexes. Don't worry about like, space right away. Okay. Okay. So we're actually at the end of this PDF. Has it been useful so far, this presentation? Like, have you learned something? Like, yes or no in the chat? I hope it's a yes. Oh, thanks, Ivan. Oh, you're too kind. Cheers, man. Like, I know we're going over stuff that we've got already, but people emailed me like back all the time saying like, oh, I didn't really understand this part of the PDF MySQL best practices. Like, could you go over this? And that was like by far the most popular request in the emails I got back when I talked about the webinar. Oh, cheers, Dervis. Am I saying that right, Dervis? Dervish? Sorry, I'm if I'm saying it wrong. Okay, so let's move on. So let me move this over to the left side so it doesn't block the view. Okay, so I emailed you about this, I think it was last week or the week before. So the SQL Sage website, the backend, is where I put all the free training. So this is completely free, like, you know, it's open. If you downloaded MySQL practices, then you get full access to this. And I'm adding content to it whenever I can. I haven't added content to this week, purely because of the webinar, but I'll be adding content whenever I can to it. And this one, actually, let me just show you the index. So here on the left, I'm pointing to, so free learning materials, you've got access to the MySQL practices, MySQL from start to finish. So this is all like my, well, it's going to be a 6-step course, but it's a 5-step course at the moment. And it's a video course where I show you how to write, oh, sorry, not write, make a MySQL server from scratch. And like for you guys, Ivan and the other guy who are new, like this would be really good for you guys to learn, like go through this stuff. Because even like going over the basics, like it might seem like silly, but like the best martial artists practice like the most basic stuff all the time. And even you guys who are like really experienced, like this might seem like, oh, I know how to write a MySQL, you know, config file, but like there might be some stuff in there that you didn't know. And like SSL encryption, that's the most important one in my opinion, because like I found in my job, almost nobody knows how to do SSL encryption in MySQL. If you go to an interview, by the way, and say you know how to do master slave replication, SSL encryption, you're ahead of 90% of developers. I'm serious on that. That is serious. So definitely check out this free training. It's all there. It's going to be there forever. When you get a chance, check it out. So I've linked it in past emails if you need to go to it, by the way. And if you ever need to log in, so if you go to the site and it says, oh, log in, then if you put in the email address that you subscribe with to download the MySQL practices, that'll work. And you'll get a magic login. Okay. So it's 3:45 in my time zone. It'll be about an hour or two ahead for you guys. Okay, so MySQL speed cheat sheet. Vladimir. Fortunately, I'm now showing webinar. Yeah, of course, yeah. I'm recording this, Vladimir. So I'll write into a file, MP4 file, send it to you. It's cool, don't worry, man. It's cool. It is a Sunday, so I understand got things to do. And it's our day off, so I appreciate you coming, Vladimir. Cheers. So, all right, let's start. So, cheat sheet. So these are my best tips and tricks for getting the best performance out of your MySQL server. So these come from my user experience, working as a developer, and what I've learned from people with more experience than me. These are in a quick-fire, digestible format with some discussion added where applicable. Okay, so these are like, you know, there's like BuzzFeed, like, you know, 10 things you wouldn't believe. Like, I try not to be like that. I try to like keep it simple, but like actually explain where I put points. Okay, so these are my quick-fire do's and don'ts. So these are my favorite tips, and performance will vary by order of degrees based on how big your database is. Like I said before, like if you've got like millions and millions of rows, then you should already know this stuff. And if you don't learn it now, if you're starting out, then you're doing more than enough by just learning this stuff. So don't worry. Okay. So write your indexes for the most common queries. Covered that. Avoid ORs. Unions are always faster. So this is something that I get into a lot of arguments with at work, especially with data analysts. They'd like to use ORs in their where clauses. So like if you put like where, I'll have to write this. like that in the chat. So like that actually isn't very performant. Less performant than you might think. Just think about it, like if you've got MySQL's optimizer, it has to basically split the query into two. So you better have an index on col1 and col2 for that. Unions are something that I'm not going to get into necessarily here. Like if you don't have to do unions, don't worry about it. I'll send out some more content about that soon, but they are a good way of running database queries. Subqueries are useful. Not going to go too much at some of these. I don't want to go too much into them, but okay. So this one, explain. Okay, explain is one that we can definitely look at here. So explain gives you the clues you need to diagnose slow queries. So like if you're writing a query for your app and you're not sure, just write it like this. So if you say it's like select star from table, yeah, or like for example, select star from table where col1 equals 1, right? Like that. And you're like, you want to actually analyze this query before you run it. What you do is you do this, so explain like that. And all that does is, I mean, like most SQL programs like SQL Pro, Datagrip, IDSQL, they have like automatic tools for this. And basically explain will give you an output to sort of tell you how many rows it'll query, which is important. So like if you've got a big table, you want to make sure that you're filtering down the number of rows. And if you followed the indexing guide before, you'll do better. Okay, so think about the columns which join onto a table. Okay, so make sure if you're joining on tables that the columns you're joining on are indexed. So like, so I'm going to select, I'm going to copy and paste this. Okay, so table 2, so on, say if I do like col2, so I'm just typing this col2 equals table 2 col2. Let me just see if I've actually written that right. Okay, so this is in the chat by the way, guys. Like on table 2, you need to make sure that col2 is indexed. You don't necessarily need to care about col2 being indexed on table 1 because you're already doing where col1 equals 1. And if you have a composite key on col1, col2 on the first table, that's fantastic. But most importantly, you need to make sure that col2 is indexed because you're saying effectively in this on clause, you're joining each row to each row based on the table 1's col2 is equal to col2 on table 2. So you don't care about col2, you're saying like, I've got the row now, I want to find the table, or the row, sorry, in table 2. And that's why you need col2 to be indexed in that join. Okay. Limit 1 is redundant. Okay. Indexing, we've done this to death in previous stuff. Index is greatly misunderstood among developers. I've already ranted to you about that. Okay. So what all these actually were talked about in MySQL practices. So think about cardinality. So if the index reduces to no fewer than 20% of the table's rows, it won't be used. Because there's actually less work to read from disk, all the entire table, than to bounce between the index and memory and the data. So like if you've got like a field and a table where it's like, let me write this down, so 1, 1. Like this. So if say in your table you've got this many rows, okay, and you were saying, okay, select from this table where whatever this column is 1. It's like, well, dude, like 5 out of all these are 1. So actually it's more work to do an index scan than to actually do a full table scan. How crazy is that? There's something you need to know and be aware of. Covering indexes. Okay, that's something I haven't covered yet. So a covering index is where every column in the index is also being selected. So let me type this down. So select col1 from table where col1 equals 1. Okay. Okay, that's kind of a bad example. Let me just hang on. That's a bad example. Let me just because you know it's 1, right? You're saying select 1 where 1. Sorry about that. Let me just call to more than 2. Okay. Okay, so you got this. Done it wrong again. Sorry guys. Right, col 1, col 2 from table. Okay. So you're saying, okay, you've got an index in table, so you've got a nice index on col 1 and col 2, composite key, and you're saying select col 1, col 2 from table where col 1 equals 1 and col 2 is more than 2. So col 2 actually has a range of values. Okay. What MySQL can do here is say, aha, you're only selecting from this table col 1 and col 2. These are already the columns that you've got indexed, so I can read them directly from memory. So if you have this situation, guys, this can be the biggest speed boost you can get. So, like, doing select stars, like that, I guarantee you don't need that most times. That's kind of bad practice. Like, so if in your app you're relying on a field to have a certain name, so like you've got a variable that you're fetching out from, so PHP, like Ivan, and there's the other guy, like if you're doing that and somebody changes the field name, your app's broken. So make sure that when you're doing it, you put explicitly, so select col 1, col 2, right. Okay, partitioning. We can go over this like a little bit, like I'm not going to go over too much because it's kind of like an advanced topic. It can be one of the quickest wins for queries in your biggest tables. So say if you've got like some, I've got a table in my work that's about 20 gigabytes, and the front end of the app that we have was really slow. The page that uses query on this table. But once I partitioned it by date, what that means is I split the table into sections based on the dates of the rows. So if each row is like a certain date, and I say actually, okay, split 2017, 2016, 2015 into their own partitions, that effectively means that each partition is its own table. So if you can say, okay, only select for this chart on the front end, data of 2017, I can like filter down to the fifth of the data that I need to get. So that can be a big win. I have written in detail about partitioning and the types. So there's range partitioning, hash partitioning, and there are more. There are others, but those are the main two: range and partition. Range and hash. They're good to learn. If you're already well established in your job and you have big tables, look into partitioning and read about hash partitioning. But let me just scoot up quick. So like I've actually got a guide here. Can you see on the left here, down here? MySQL Partitioning Basics. That's my guide for this. So make sure you check that out. Okay, moving on. Server configuration. Okay, so I think we're getting close to the end here now. I'm not going to go too much over 4 o'clock because I've been going for almost an hour now. So when I'm talking about configuration, I'm talking about the my.conf file that you have on your server for MySQL. So this is kind of advanced. Let me just take some water. Sorry. So in my MySQL from start to finish course, I actually go over an entire lesson on the my.conf file to try and optimize settings. And like partitioning, guys, this is kind of more if you're already established and got a database set up with actual data, and you've got, at least hundreds of megabytes of data. You start to need this stuff. But it's always good to know, like, don't just ignore the stuff just because it's, it's advanced stuff. So the biggest thing is InnoDB buffer pool size. Set that variable to 70 to 80% of your RAM if the server that you've got is only for MySQL. So there's a bit of a misconception about the query cache in MySQL. So query cache is a setting, or a group of settings, that actually isn't used much. If your data is changing at any point, the query cache, which is kind of like Redis for MySQL queries. So basically it says like, okay, I've got this query, did a select query, so I did select col 1 to col 2, and got a result. 5 seconds later, the same query, data hasn't changed, return the result. Dead fast. Sounds awesome, right? But the second that data changes in the table, the entire query cache is wiped out, all of it. A lot of the actual caching that MySQL uses and benefits from in the application is InnoDB buffer pool size. And that's provided that you're using InnoDB tables. If you're new to this, guys, or you've got existing MySQL tables, always use InnoDB tables. There is no longer any benefit to using MySQL tables over InnoDB. InnoDB is more transaction safe, it's now faster than MySQL, and in MySQL 5.7, it can handle geospatial indexes. It's just far better, don't use MySQL. And if you have legacy tables, convert them as soon as you can. At work, at my job, we have loads of problems dealing with old MySQL tables. And that's because we're working with 5.6 at the moment, and I'm trying as hard as I can to get them to use 5.7 to get geospatial indexes. And also, like, if you join between a table that has MySQL and InnoDB, that entire MySQL table is locked to any other select query. So how crap is that? Like, anyone else can't access that table while that query is going. So your query better be fast if you're using a MySQL table. Otherwise, the entire table is locked up. Okay, I'll write some more stuff about some more config options. These are the 4 most generic ones that can help. Don't worry too much about these. I mean, yes, put them in, but just kind of leave them and forget about them. Don't worry about them. Timeouts. Yeah, they're more for kind of big imports and exports, which I do have a section on and the website. MySQL Migration Masterclass. Okay, moving on. Hardware. Okay, so the actual server that you've got your MySQL sitting on. Okay, so like you obviously want like plenty of CPU, RAM, right? Enough space for the data. Unless you're like balls to the wall, like 100% CPU all the time, optimize slow queries first before worrying about the hardware that you've got. So do you guys run like EC2s on AWS, DigitalOcean, that sort of thing? Like, that's kind of a good thing. I mean, they're great, but don't worry too much about the hardware you have. Like, don't worry about having like terabytes of RAM, that kind of crap. I mean, unless you're like Facebook. Always prioritize optimizing your slow queries before, doubling your RAM. I mean, obviously that helps, guys. I mean, like, I'm not saying don't do that. I'm saying like prioritize optimizing the bad stuff first, the queries. Okay. A single MySQL connection will only use one thread. So highlighting a single core. So if you've got one of your cores in your server, quite high load 100%, that can indicate a single slow query, because MySQL will only ever use one thread on the CPU. SSDs are standard nowadays. If you're using spinning drives, just buy an SSD. And if you've got no option but to use spinning drives like hard drives, then split the load for reading and writing between 2 drives or 2 servers. But really, they're not that expensive, guys. SSDs. MySQL also will use all the RAM you give it. So like if you say so in this section here, like I said, InnoDB buffer pool size, 70%. The reason I say 100% is because MySQL will use every single byte of that RAM. And that's a good thing, because it means that like it'll cache as much as it can in memory. So all your tables, all your queries get cached there. And it'll make your app faster. Okay. And we've literally just hit 4 o'clock as we've got to the end of that. Okay, so let me go back to the chat. Let me show the whiteboard again. So if I go back to, how do I do this? And sharing. Okay. Whew. So that was a full hour talking about MySQL. Okay, so we got through, had a quick chat, found out Ivan likes Pain, likes Java. I told you about SQL Sage while I'm doing it. I went through the points in the MySQL Best Practices PDF, which I think you guys quite enjoyed, quite got a lot out of, yeah. MySQL at Speed cheat sheets, which has been through. Went through some of the points there. And now, do you guys have any questions for me at all? If you have any questions, put them in the chat, and we'll see what happens. But thank you guys for now. Thank you so much for coming for this hour and sticking with me. I really hope it's been useful for you guys. I mean, I'm not asking for anything in return. I just enjoy doing this. Like, if you want me to go over anything in the past that I've gone through, then let me know. Like, anything you didn't understand, and I'll try to answer. My tea's gone cold. It's cool, Ivan. You're welcome. Glad it helped you. My tea's gone cold. Damn. Cool. So yeah, I'm going to record this, or I've recorded this now, and send it out to you guys. Actually, it's going to be quite a big file, so I don't know how I'm going to distribute this. I might put it on a S3. Oh, okay, that's fair enough, man. That's very kind of you to say, thank you. Yeah, you got my email, so if it's like a long question, then, you know, I'm not fussed. I've got all day here, so. Oh, sorry, man. Sorry, Ivan. I didn't realize. Yeah, of course. I've got the video, so I've recorded it into a file, so you're welcome, Vladimir. So all of you have a good Sunday. And I keep saying thank you, but thank you for spending an hour with me today, talking about MySQL. I'll try and do these more often as well, these webinars. This is my first ever webinar, so I hope I was okay. We got some typing. Oh, thanks, guys. That's so kind of you. Thank you. Vladimir's here for a second one. Okay. Thanks, Ivan. Yeah. Okay. You're welcome, Dervish. Thank you. Glad it helped. If you guys have questions, like if you go away now and like if you say like, I didn't understand that, feel free to email me anytime. You're welcome. You're welcome. Okay, well, if we don't have any questions, then I guess we'll call it a day. We'll end the webinar. Okay. Let me just put this out. Okay, thanks, guys. Bye. Goodbye. I will do that, Dervish. Go for a beer, definitely. Bye, guys. Bye.